Hello friends, a very good morning to all the students present. Am I audible to all the students? Okay, thank you friends for giving me your response. So dear friends, we are discussing one of the interesting unit of basic mechanical engineering. The unit is the practical one and the unit name that is the steam boilers. And dear friends, if you remember in the last session, last lecture, we have understood the important concepts related to the steam boilers. In the last lecture, we have understood the main parts of the steam boilers. And then we have understood three most important types of the steam boilers. They were the Cochrane boiler, the Lancashire boiler, and the Babcock and the Wilcox boiler. Dear friends, let me inform you once again, all the boilers, the three boilers are very important related to the examination. The vertical boiler is not in your syllabus. Therefore, I have not explained the concepts of the vertical boiler. So you can skip the vertical boiler during the preparation. So friends, for the answer of the boilers, it is very necessary, it is very important, it is compulsory to draw the figure of the boiler. And let me advise you that you need to practice the figure several times. If you see the figure and try to recall the figure during the examination, you will not remember the points and it will take a lot of time during the examination. So my suggestion, my advice that you draw the figure several times and practice the figure, practice the labeling and all the components so that during the examination, you can easily remember the figure, draw the figure perfectly and score good marks in the examination. So now friends, let me ask you some few questions related to the topics which are discussed in the last session. In the Lancashire boiler, what are the number of the flue gas paths? How many are the path of the hot gases in case of the Lancashire boiler? Or what is the number of the paths in case of the Lancashire boiler? The path of the flue gases or the hot gases. Understand the question perfectly and then give me your answer in the chat box if you have understood the question. What are the number of the flue paths, the hot gases paths in case of the Lancashire boiler? Any student is knowing the answer, you can give me your answer in the chat box. The right answer, that is three paths. The first path, that is in the main flue pipe, that is MF. The second one, that is the BF, the bottom flue path. And the third one, that is SF, is the side flue path. So these are the three different flue paths in case of the Lancashire boiler. And because of these only, there is maximum heat transfer and the steam is generated at the medium pressure. My next question is, the Babcock and Wilcox boiler is a fire tube boiler or water tube boiler? The Babcock and Wilcox boiler is a fire tube boiler or water tube boiler? What is the type of the boiler? Okay, so I have got the answer from the students. The perfect answer, the Babcock and the Wilcox boiler, that is the water tube boiler. Because we have seen in the working, the water is collected in the tubes and surrounding the inclined tubes, the hot gases are moving and there is the heat transfer. So I hope the concepts are clear in your minds related to the three types of the boilers. Repeating the point once again, all the three boilers are very important considering the theoretical examination. Baffles are the devices which are used in the Babcock and the Wilcox boiler in order to give the direction to the hot gases. In the Babcock and Wilcox boiler, the hot gases are moving in the sinusoidal pattern. So in order to create that pattern, the baffles are provided in the Babcock and Wilcox boiler. Is it clear to the student who has asked me this question about the baffles? Okay, fine. Thank you for the response. So now friends, let us proceed further and understand the concepts about the boiler mountings. So boiler mountings, the term you have come across several times during the discussion of the steam boilers. So now we will be understanding the concepts of the boiler mountings, and also in this lecture we will be discussing in detail the four types of the boiler mountings. They are the pressure gauge, the water level indicator, steam stop valve, and the feed check valve. So let us start with the current session. The boiler mountings. The boiler mountings are the fittings and the devices which are mounted on the boiler for the safety of the boiler and for the complete control of the process of steam generation. Boiler mountings, very important fittings or the devices when we consider the safety of the boiler, as well as they are very important in controlling the process of the steam generation. Dear friends, let me highlight this point. Boiler mountings are very important for the steam boilers. The definition is also important. It is several times asked in the examination. So let us repeat the definition once again so that you can remember and understand the concept. Boiler mountings are the fittings and the devices which are mounted on the boiler for the safety of the boiler and for the complete control of the process of steam generation. According to the IBR, the following mountings should be compulsorily fitted to the boilers. Dear friends, what do you mean by IBR? What is the full form of IBR? Anybody is remembering? What is the full form of IBR? We have already discussed this point several times. I have highlighted this point during the definition of the boiler. Very good. I have got the responses from the students. IBR, that stands for the Indian Boiler Regulation. We have already understood that it is an important body which is concerned with the steam boilers. So according to the guidelines provided by the IBR, the following mountings should be compulsorily fitted to the boilers. The boiler must be fitted with two different types of the safety valves. Also, the boiler must have two water level indicators. A pressure gauge must be having, a steam stop valve must be mounted, a feed check valve, a blow-off cock, an attachment for the inspector's test gauge. So during the inspection, the person can easily check from this attachment some of the important parameters related to the boiler. And the next one, that is the manhole. The final one are the mud holes or the sight holes. So these are the different mountings in their specified numbers, which must be compulsory mounted on the steam boilers according to the guidelines provided by the Indian Boiler Regulation, that is IBR. So let us now proceed further and understand the different boiler mountings in detail. The first and the important boiler mounting, that is the pressure gauge. The function of the pressure gauge is to measure the pressure of the steam generated inside the boiler. Because friends, it is very essential to note down or measure the pressure of the steam generated inside the boiler, so that in the cases when very high pressurized steam is generated, high pressure is generated and it is noted by the boiler operator, then he can immediately take the safety measures. If the pressure is not noted, if the pressure is not measured and suddenly the pressure increases in the boiler drum, then there are chances of the explosion and a very high accidents may take place. So all the boilers must be fitted with at least one pressure gauge, and the pressure gauge is usually mounted at the front top of the boiler shell or the drum, so that the boiler attendant or the boiler operator can easily take the pressure readings from the pressure gauge. And friends, the boiler operators, the boiler attendants are compulsory told to take the pressure readings at particular times during the operation of the boiler. It is very important to note the pressure readings. Generally, considering the types of the pressure gauges, there are two types of the pressure gauge which are used. The first one is the Boulton tube pressure gauge, and the second one is the diaphragm type of the pressure gauge. But when we consider the simple applications, in majority of the cases, the common type of the pressure gauge used for the steam boilers, that is the Boulton's tube pressure gauge. So this is the basic understanding related to the pressure gauge. Now let us understand its construction as well as the working. Remember friends, whenever you are writing down the answers of the boiler mountings, discussing the answers, again it is very compulsory, it is necessary to draw the figures of the mountings, that is the boiler mountings. From the figure only you can understand the concept and you can write down the answer. So the main components of the pressure gauge, and this is the image, the construction of the Boulton tube type pressure gauge. The main components are the U-tube siphon pipe, the lever handle, the test gauge connection, the Boulton tube, very important, having a C-shaped construction. You can see that the design of the Boulton tube is of the C shape. One end of the Boulton tube is connected with the U-tube siphon pipe, where the other end is connected by the linkage, and it is connected to the quadrant mechanism, which is having the toothed wheel. You can see the teeth are provided on the quadrant. The quadrant is further connected to the pinion, and on the pinion, the centermost part, the needle is provided, and outside the Boulton tube, a dial is provided. so that by the movements of the needle on the dial, we can measure, or the boiler attendant can measure the pressure or can note down the pressure. Now let us understand the working of the pressure gauge. Bourdon tube pressure gauge working is very easy. The steam which is generated in the boiler, that will be affecting the water which is collected in the U-tube siphon pipe. Because of these effects of the steam on the water collected in the U-tube siphon pipe, this U-tube siphon pipe will try to straighten itself. This U-tube siphon pipe will undergo to straight itself by the effects of the pressure of the steam. The movement of the U-tube siphon pipe will be taken by the Bourdon tube. The Bourdon tube, the C-type Bourdon tube, will try to move in the outside direction. Means there will be a minor expansion of the C-shaped Bourdon tube. This Bourdon tube will try to expand in the outward direction by the effects of the movements in the U-tube siphon. This movement of the Bourdon tube will be taken by the linkages and the pinion attachment. And the movement of the pinion will be transferred on the needle. And in the initial conditions, there will be tremendous movements of the needle on the dial. So because of these tremendous movements, we cannot get the exact value of the pressure. But as the time is proceeding, when there is the equilibrium condition between the steam and the water collected in the U-tube siphon pipe, the operation of the needle will be stopped at one particular pressure, and that pressure can easily be noted from the dial. So this is how the boiler attendant notes down the pressure, and this is how the working of the Bourdon tube pressure gauge takes place. Dear students, I have explained the working in very simple language, simple manner. I hope you have understood the working of the Bourdon tube pressure gauge. Is it clear to all? Or if you are having any questions from your side related to this pressure gauge, you can ask me your doubts in the chat box. Or other way around, if you have understood the concept, then also give me the confirmation that we have understood the concept, so that after getting your positive responses, I can proceed further with the next mounting. Is it clear to all the students? Or if you are having any doubts related to the Bourdon tube pressure gauge, you can ask me. Very easy to understand. Just you need to think some technical perspective, draw the figure and just explain the working construction by your own words, and the technical concept is clear, then definitely you will be getting good marks in the examination. So thank you all. I have got some positive responses from the students. So now let us friends proceed further with the next type of the boiler mounting, that is the water level indicator. From the name only we can understand that this mounting is used for measuring the level of water in the boiler. So the function, the purpose of the water level indicator is to indicate the level of water in the boiler and to enable the attendant to regulate the supply of the feed water in the boiler to maintain the correct level. Dear friends, in the practical approach, the boiler attendant also needs to compulsory note down the water level. You need to take the two readings on the continuous basis. Firstly, the pressure of the steam generated from the pressure gauge, and secondly, the water level which is contained in the boiler. It is one of the safety device upon which the correct working of the boiler depends. If the level of the water reduces suddenly, then there are chances that because of the low level of the water temperature can be increased, the pressure can be increased suddenly, and there are chances for the explosion. So according to the IBR, they have given the guidelines to install the two water level indicators because of its importance. If one of the water level indicator gets failed, then the boiler operator can easily take the readings from the second water level indicator. And both the water level indicators will be fitted in the front side of the boiler in order that the boiler attendant can easily note down the readings from the water level indicator. Let us now understand the construction and working of the water level indicator. So these are the main components. Remember friends, the water level indicator is always installed, located at the intersection of the steam space and the water space. If you see the three types of the boiler, Cochrane boiler, Lancashire boiler, Babcock and Wilcox boiler, in all the boilers, you will be observing the water level indicator that is installed between the intersection of the steam space and the water space. In this construction, one of the pipe, one of the tube is connected with the water space. On the top side, the another tube is connected with the steam space. The water tube will be having the water cock, the steam tube will be having the steam cock, and supporting these two tubes, we are having the glass tube. The glass tube will be surrounded by the stuffing box. In the water tube, we are having the water cock, which is regulating the flow of the water entering the water tube. In the steam tube, we are having the steam cock, which will be regulating the flow of the steam in the steam tube. Then we are having the ball valves in each tube and the drain cock. The drain cock is used to drain out the water completely from the boiler. Now let us understand the working of the water level indicator. For measuring the water level inside the boiler, the water cock and the steam top must be opened completely. Both the cocks are opened completely. So because of this opening of the water cock, now the water rushes into the water tube and the water starts filling in the glass tube, the vertical glass tube. Similarly, on the top side, by the opening of the steam cock, the steam rushes in the steam tube and the steam is collected again in the glass tube. So in the glass tube, there will be the contact of the steam and the water. During the initial conditions, the water level will be moving up and down, up and down. There will be no fixed level of the water. But when the equilibrium conditions are reached between the water and the steam space, now the water will be steady at a particular level. And behind this glass tube, there will be a graduated scale. A simple scale will be attached. So on the basis of the height of the water in the glass tube, the boiler attendant can easily note down the level of the water. So this is how we are using the water level indicator. The stuffing box is only used for preventing the leakages. In the above side, it prevents the leakage of the steam. In the below side, it prevents the leakage of the water. Now friends, understand the next concept. In any case, if the glass tube is broken, If because of the improper working or carelessness of the boiler operator or because of some external conditions, the glass tube is broken, then comes the working of the balls which are provided. When the water cock is open and the steam cock is open, now the steam will be hitting the balls. That balls will be coming down in the metal tube. The water will be forcing the ball of the water tube. That ball will be lifted in the metal tube. So the boiler attendant will now get the reading of the height of the water. That means the height through which the water ball has been lifted in the metal tube. And this metal tube will be made of the transparent material. But it is just used in case when the glass tube is broken. So it is just a safety parameter. But generally, friends, in the practical approach, the boiler attendants are very serious during the operation of the boilers, and continuously they are observing the pressure of the steam, the level of the water. So the chances of breaking the water tube in the water level indicator, the glass tube breakage, are very less. But in any case, when the glass tube is broken, then additional safety precaution is taken of the metal tube, and by the operation of the balls, the boiler attendant can take the readings of the water level. Dear students, are you understanding the point of the water level indicator? Have you understood this concept? I am repeating again and again. If the technical points are clear in your minds, you can easily draw the figure and explain its construction and working perfectly and score good marks in the examination. Let me know from your side, is the concept clear to all? The water level indicator? Okay, thank you friends for giving me your response. Let us now proceed further with the third boiler mounting, that is the steam stop valve. The function of the steam stop valve or the junction valve is to stop or regulate the flow of the steam from the boiler to the steam pipe, or from one steam pipe to the another steam pipe, or from the steam pipe to the prime mover, that is the turbine or the engine. In some literatures, the steam stop valve is also known as the junction valve. This valve is used for regulating the flow of the steam from the boiler, or it regulates the flow of the steam from one steam pipe to the another steam pipe. This valve is usually mounted over the boiler drum in the steam pipe leading to the steam turbine or the engine, or it is mounted between the steam pipes in order to stop or regulate the flow of the steam. Function is very easy to understand. Also, the construction and working of the steam stop valve or the junction valve is also easy to understand. So let us now understand the steam stop valve, its construction as well as the working. The main components are the flange, which is connected on the boiler shell. The valve is seated on the valve seat. Remember friends, the valve and the valve seat both are the different components. The valve is seated on the valve seat. The outer covering is the body. The spindle is connected with the hand wheel. The stud assembly is given. The gland is given. The gland prevents the leakage of the steam from the steam stop valve. Now let us understand the working. Is very easy to understand. Whenever we need to have the steam at the outlet, The boiler operator will be operating the hand wheel, rotating the hand wheel. So because of this rotation of the hand wheel, the spindle will be lifted in the vertical direction. Because of the movement of the spindle in the vertical direction, the valve will also be lifted in the vertical direction. So the space in the body will be opened. Now the steam can easily enter in the steam stop valve and it can easily be removed from the boiler, and the steam can be passed to the particular application, that is on the prime mover, steam turbine or the engine. In case when the flow needs to be stopped or the flow needs to be regulated, the boiler operator will again move the hand wheel. Now the spindle will be moving downwards. With the movement of the spindle in the downward direction, the valve will be seated on the valve seat. So now there is no space for the steam to enter the body. So the steam cannot enter the body, and at the outlet of the valve there will be no steam moving out. So this is the simple working of the steam stop valve. It is completely operated by the hand wheel, the movement of the up and down movement of the spindle and the valve. Very easy function. The steam stop valve or the junction valve is used for regulating the flow of the steam. Dear students, have you understood the concept of the steam stop valve? I want your responses if you have understood the concept. Flange is just used for the connection purpose of the valve with the boiler drum. It is a type of coupling. It is used for the connection. Okay, have you all understood the steam stop valve perfectly? I want your responses. Okay, thank you friends. So now let us proceed further and understand the fourth boiler mounting, that is the feed check valve. The function of the feed check valve is to control the supply of the feed water to the boiler from the feed pump, and it prevents the water from escaping back from the boiler in the event of the failure of the feed pump or in the conditions when the pump pressure is less than the boiler pressure. So simple sense, the feed check valve is used to supply the feed water to the boiler from the feed pump. Also, in case of the differences of the pressure from the pump side and the boiler side, the feed check valve also prevents the backflow of the water from the boiler to the feed pump. Generally, the feed check valve is fitted over the boiler shell slightly above the normal water level of the boiler. Let us understand the construction and working. The main components of the feed check valve are the non-return valve, which is connected to the inlet pipe. Then again we are having the spindle, the gland and the hand wheel. The two pipes are there, the inlet pipe that will be connected to the feed pump and the outlet pipe, the delivery pipe that will be connected to the boiler shell, the inlet of the boiler. The gland is provided in order to prevent the leakage of the feed water. So now friends, by the pressure of the feed pump, the water will be high pressure in condition will be entering the feed check valve. By the high pressure of the water, the non-return valve will be lifted in the above direction. Because of this lifting of the non-return valve, the water can easily fill the body, and now the high pressurized water can easily enter the boiler. in case when the water must not be stored in the boiler, must not be entered in the boiler attendant will operate the hand wheel. The spindle will be moving downward direction. The spindle will be heating the non-return valve. The non-return valve will be fitted in the inlet pipe. It will be positioned in the inlet pipe, and on the non-return valve, the spindle supporting structure will be fitted. So the high pressurized water will now cannot lift the non-return valve. Since the high pressurized water cannot lift the non-return valve, it cannot enter the boiler. And in the case when there are the pressure differences from the boiler and the pump side, as we are knowing that in the boiler we are generating the steam, so obviously the boiler pressure will be higher than the pump pressure. So in case of these differences, the boiler pressure will be forcing the non-return valve again to move in its original position. Therefore, the water which is already stored in the boiler cannot backflow in the pump. Hence, the name is given of the valve, that is the non-return valve. The water cannot return back to the pump assembly. Once the water has filled in the boiler, compulsory that water needs to be converted into the steam. And in the case when the boiler operator does not need to fill any water in the boiler, it will be operating the hand wheel, the spindle will be moving down, the spindle will be forcing the non-return valve, fixing the non-return valve in its original position. The feed water cannot enter the body, and now no feed water will be collected in the boiler. So friends, is this concept clear to all related to the feed check valve? The feed check valve is used for regulating the flow of the feed water. Let me ask you the question, have you all understood the concept of the feed check valve? Any doubts, any question from any student are welcomed related to the feed check valve. Remember friends, the technical difference between the steam stop valve and the feed check valve is in the steam stop valve, the valve is having the additional valve seat. The valve is connected with the spindle. But in the feed check valve, the spindle is different and the valve is different. So these are the most important technical differences in the design of the steam stop valve and the feed check valve. So friends, with this, I am concluding this session from my side. Thanks for watching the current session. I hope you have perfectly understood the concepts of the boiler mountings which are covered in this session. Have a nice day. Now, dear friends, if you are having any questions related to the topics covered, you can ask me in the chat box. For the preparation, the figures are very important in the boiler mountings. Any question from any student?